All right, so good morning, everyone. We're going to get started here. I'm just going to ask the co-presenters to make sure they're muted so we don't get any background noise here. Thank you for joining us today. My name is Martin Galanders. I lead our services and solutions team, and we have a team of specialists here on the line today to help answer any questions you might have as we go through the presentation. We're going to talk about data collection and dashboarding today. We're happy that you could join us. We appreciate you being on the line with us today. We know taking 30 minutes out of your day is a challenge sometimes, so we really appreciate your time. We're going to have 30 minutes full of content here, but feel free to ask questions in the chat, and then at the end of the session, we'll open it up so that you can ask any questions, and then we'll be happy to provide any answers that we can. And we will reach out to you after the session with a copy of the presentation and answering any questions that remain unanswered at that time. These sessions are also being recorded, so if you miss a session and you want to get a copy, feel free to reach out to anybody on the line here today. We'd be happy to provide any information we can and a copy of the presentation moving forward here. So let's go ahead and get started today. I want to talk a little bit about the data journey and what your data journey looks like, what a typical journey might be, and how we kind of progress through that. And it really all starts with determining what the result is that you want to see out of your data project. And this is typically where most customers struggle and where we try to help you define really what you want out of the project. What are you looking for? What results are you looking for? And collecting data just for data's sake is not important. So we want to make sure that you have a good understanding of what you want out of the project, and really determining what that result, what that end goal is something we can help along the way. The second piece here is really to collect that data, right? So once we have a really good idea of what you want out of the project, then we need to start to understand what pieces of data are really necessary for you to get that outcome that you're looking for. And this is where the scope of things like tag counts get defined, but also where we help you limit that scope so that the project doesn't become too big, so that you don't collect data that's unnecessary. And then also you have the availability to expand as your needs expand throughout the project. So really that's a key area for us is defining what that data collection looks like. The third piece then becomes, how do we interpret that data? So you can look at the tags in the PLC today, but how do we provide context around that, and how do we make it easy for you to understand, easy to ingest, and make it painless for you to ingest and for others on the team to really understand. And then the last piece of this is, how do we automate? How do we automate the interpretation, and how do we automate remediation, right? How do we make the system make smart choices for you so that you don't have to be vigilant of the system 24/7? And also, how do we make that easily interpreted by you? Right, so again, it's more around how do we contextualize that information? How do we bring in additional data pieces that we don't have access to today? How do we bring that into the mix? And how do we really drive a good understanding of what that data means, right? So really, this is a great picture of what this journey entails, how we can help you get there, but also the importance of understanding that really step one is vital to any successful data project. Okay. So I wanted to start a little bit with how did we start on this journey, and in the automation world, what does it look like, and where did we start? And the reality is, we started with machines, right? Our OEMs or our SIs would provide a machine to us, and then typically there'd be some kind of controller in there that would be doing any of the execution that was needed, and we'd have some kind of human operator interface. We started with push buttons, and then we moved into panel views and HMIs, and really that would give us a little bit of data and a little bit of an insight into what the controller was doing and what the machine was doing as a whole. And then the third piece that you saw on some machines would be some kind of graphing chart. So it would automatically track typically an analog input, and it would record on the chart throughout the operation of the machine what it was doing and what the machine was doing and what the variable was doing over time. And those were pretty good at tracking what was happening, but they were essentially a manual replacement of those charts, and it still took a long time to interpret what the chart meant, what the value really was, and being able to correlate that to some kind of time throughout the day. So it took a lot of effort, right? And we would take all that data, and what you typically see is somebody walking around with some kind of checklist or some kind of piece of paper where they'd write all these things down, right? They'd come throughout the day, they would double check to make sure the machine was running correctly and annotate any of those variables. And then we would shift those into some kind of Excel spreadsheet, right? So we take all that data, hopefully, and then it was a manual process to enter that into an Excel database. And then eventually you would see some kind of whiteboard or some kind of chart with sticky notes, with plenty of graphs and things printed out. But it was, again, a manual process to update all of this information, to update all of the data. So what do they look like today? Right? What's a slightly more modern approach is, now we have a lot of these machines, but a lot of them are networked and they're connected. So really, because there's the central network, we now have the ability to connect from a computer or from a server into all of these systems. And we start to talk about shifting that data into a server. So now we have an automated process. We've done away with the clipboards. We've done away with the large printouts and Excel spreadsheets. We've done away with the graphs and manual trackers, and we've substituted that for an industrial network, which on the Rockwell side is an Ethernet IP network. And we put that data into a server. And typically the platform of choice for us is FactoryTalk Historian, which some or all of you may or may not be familiar with. But essentially, Historian is what we're going to use to collect all of that data from the different machines and kind of mash it all together. Okay? So this is really a more modern approach to how we do data collection today, right? So let's take a little bit of a closer look at what we call FactoryTalk and what that historian is, right? And again, step one is always capturing the right data. So defining what that data needs to be, and then making sure we capture that data out of your controllers or out of your systems. That is at the core of any FactoryTalk historian project, okay? So that might be what the machine state is. It may be things like counters or how many parts you've cycled through. It may be whether those parts have passed or failed. Maybe it's energy usage or temperature in the machine. So those are all things that we track in the controller and that we can shift into historian and collect that data. Step two is always around storing those values, and that's where historian's data archive really comes into play. And how we store those values, what we do with them. We'll talk a little bit about how historian handles that data and how we make sure that we're collecting what you need and that it's customizable. And I just remind the presenters to mute their mics here. We're getting some background noise. And the third piece of this is the historian asset framework. So really, how do we contextualize that data? How do we make it easy for you to use? How do we make it easy for you to update? And then how do we apply some analytics on that data to make sure that we're giving you as much value out of what you're collecting as we possibly can? And these three pieces are all great, all by themselves. But the reality is, without some kind of dashboard, without something to display that data, you'd be spending a lot of time diving into all this historical data, and what happens is you don't, right? The data just collects, it sits there, but nobody really looks at it because it's not contextualized and it's not easy to read. So really then it becomes all about dashboarding and creating dashboards that are simple, that are easy to read, that are really valuable in terms of the information they give you, but also provide you that ability to dig deeper if you need to, right? So doing those calculations in terms of what your energy intensity might be, or what your OEE results are. Maybe it's percentages on how many parts passed or failed, or how often you're having to run your machine. All of those things, that analysis needs to be done up front so that you can consume that data quickly and easily, and we give you as much value out of the system as we can. Okay. So let's talk about those first three pieces and really the data collection piece. And let's talk a little bit about how it works. So what Historian does for you and why that's different to other manufacturers of Historians is it all starts with the data source, right? So our PLCs are in charge of capturing that data. They will update from I/O points as fast as you set them to. You can do high-speed I/O if you need to do that data collection very quickly. But essentially, it all comes down to how fast can we capture that data and how accurate is that raw data. And when you take all of that data and you put it into a nice little graph as we show here in the red line, you'll see that you get absolutely all of the peaks and valleys and as much information packed in as you can, right? What Historian does is we pass it first through an interface node. And what that does is it tries to take out any of those tiny little peaks that you get in the raw data that aren't valuable to you. So these are fully customizable. We can give you as much information or as little information as you like. But what we try to do is we try to smooth out the curve a little bit. That way there's less load on the network, there's less load on the system to data collect, and there's less data storage at the end of the day. So what we're going to do here is, based on the rate of change in that value, we're going to omit certain points in the graph and just skip to the first and last before the next big change, okay? So as you can see, we've gone from connecting every single one of these points to now just collecting a few along the way. What we do after the interface node and once it gets transferred into Historian is we further compress that data. And again, it's customizable, but what we try to do here is if we realize that all of these points are on a very similar line, we're going to data compress out as much as we can and give you maybe 2 or 3 points on a line instead of 8 or 9, all right? So again, what we're doing is we're compressing that data, which means now you can store more information for a longer amount of time, or we can size a smaller server for you and you have less cost in the hardware and less database needs out of your Historian to make sure that we give you this data. And this is typically something that you're not going to see with other products that rely on SQL databases. So you may see other HMI vendors, you may see other DCS vendors talk about the Historian capabilities, talk about the ability to data log. But the reality is the vast majority are using some kind of flat SQL database that isn't doing any exceptions or net bounding and isn't doing any compression. And what that means is you are storing every single peak and valley and every change in that variable that you're tracking, which equates to a very large amount of data and a very large storage needs for your system, okay? So really what we try to do is we lighten the load on the system, make sure we can run at peak efficiency, and make sure we can size hardware appropriately so that you aren't paying upfront for a very large server system that didn't need to be that big, okay? The other thing we do is we talk about asset frameworks. And really what we try to deliver with asset frameworks is a standardized way for you to look at your facility, right? We know that typically you have machines that are duplicates of other machines, right? It's very common for you to have multiple lines, very common for you to have the same machine essentially multiple times. So what we try to do here is deliver something called asset framework. And we try to simplify the way in which you configure and in which you look at your data, right? And we give you that consistency throughout the system. So a good example of what an asset framework, so we start with things called attributes. And attributes are essentially single variables within that machine, right? So it might be the temperature, it might be the pressure or the speed at which product is flowing through. It may be the actual product that you're running, so the product ID is running through the system. Those would all be considered single attributes of your system. We then move those attributes and we collect them into what we call element templates. And what an element really means is one of your machines. So maybe you have a cartoner or a case packer or a palletizer, or you have a subset of your machine or a subset of your process. That's what we call an element. And an element could have one or multiple attributes associated to it. So a really good way to think of this is in humans and in animals, right? So an attribute could be your temperature or your height. We all have a certain height, we all have a certain weight, a certain temperature. And an element could be a human or a cat or a dog, right? So those are all examples of elements that have different needs in the attributes, right? So essentially in your assets, in your asset framework, you would create these elements and tie attributes to them. And maybe in the case of humans, you would create a human, you would create a dog, you would create a cat element, and we'd all have different attributes based on the needs for that element. What we do then is we take those elements and we shift them into assets, right? And the idea here is that you can deploy as many of that type of element and that template as you need, right? So you've created a template for humans. Now we can go ahead and create Martin, we can create Jeff, we can create Adrian, we can create all of the different people as different assets that we maintain, right? And any change to the template is automatically going to propagate into those assets, right? So if I need to add a new characteristic to all humans, it automatically populates to all of my assets, okay? So you may have, for example, a template for a cartoner, and then have multiple lines that have a cartoner or multiple different parts of your project that have a cartoner, and those would be assets within the assets framework. So this really simplifies how we deploy a historian and how we make it easy for then you to search through the data and create a dashboard that is for all cartoners and then can be very specific to each one as you need it, okay? So again, why would you use historian and FactoryTalk historian against some of the third-party solutions out there? And we talked a little bit about how we compress and how we do dead banding to ease the load on your system. But when you use FactoryTalk historian, you're also tying into the common activation and the common directory. What that lets you do is pass users and pass users and computers and pass security policies throughout your system. So whether you're using FactoryTalk Historian or View SE or Studio 5000 or any other piece of Rockwell software, we all rely on this common directory. We all use the same activation types, and that allows us to do security across the platform. It also eases things like diagnostics and audit trails. Because we're all using the same directory, we can know who did what and when, so that it's easy to diagnose and easy to audit after the fact. And we can also provide live data and alarm and events as part of our historian, right? So we can seamlessly tie these things into our system throughout the project. The second part of this is really around dashboarding. The question is, why do we dashboard? And if you joined our session last week, you may have seen a similar slide, but it's all around the intent of being able to detect an anomaly, right? So we have these mountains of data that we've collected. We have all this information. What we really want to do is detect whether there's a change in the system that we need to operate on. We then want to be able to quickly diagnose what that dashboard is trying to tell us, what information it's trying to pass to us. The reason we try to diagnose is essentially we want a response, right? We want to detect that anomaly in the system as quick as we can, and then we want to get to responding to that anomaly as fast as we can and making as smart a decision based on that information as we can, right? That's really why we want a dashboard. And really it comes down to, from a historian standpoint, the part that interests most customers is the ability to notify personnel. So based on a trigger, which could be a historical value, or it could be a time-based trigger that happens every day or every week or every hour, you want to be able to notify of an event to certain personnel, whether it's the maintenance team that they need to go and take a look at the machine or do some predictive maintenance, or if it's an operator that they need to perform some kind of corrective action, or maybe it's the management, you want them on a weekly basis to receive a notification with everything that's happened with the system. So really that ability to generate and publish reports, to send emails, to attach that report to that email, really make it simple and easy for operators to consume that information. And then also have things like SMS, text message notification, so that via mobile platform, you can alert your operators when something has changed, or maybe you can notify the maintenance team, and then let them know exactly what the issue is and where that issue is happening. Right? We also have features around Trend Pro, so being able to trend multiple pieces of data, create dashboards out of trends, and really the key part here is this is the same Trend Pro object that we have within FactoryTalk ViewSE. So the operator experience is common. It is the same object that you see in ViewSE, is what you see in Historian. And it really allows us to be very simple and look at both live data and historical data and superimpose that data as needed, right? And we can then export that data into Excel and other formats for you to consume and digest if you need to in a separate report. We also have a set of features around reporting with Excel, and the reality is most people are familiar with Excel, know how to create reports, know how to create different types of graphs. They find it intuitive and fairly easy to use. So rather than recreate the wheel, what we do is we take those Excel reports that you can create, and then we can publish them into our reporting tools, so it's nice and easy and simple for you to create your own reports. So really the value here is in making it very easy to collaborate, very easy to create reports, and then ensuring that you have data integrity across your system when we try to pull the report from that historical data. Next, what I want to do is talk a little bit about data collection as a future. And what we've talked about so far is something that's typical and you see in multiple facilities across multiple customers. But really, where are we going and where is the value of the future? Right? So the future of data collection really involves having multiple sites and multiple servers. So you may be working at a facility today and you know that you have other facilities spread across the US or the world. And what we want to do is bring those isolated facilities together. And where we're going to bring them together is the cloud. And we want to make sure that we do that in a safe and secure environment. But we want to make sure that we can pull all that data and be able to give you comparisons of how different facilities are running, so that then you can make smarter decisions on where to shift that production, what facility is operating better and why. So you can start to make more informed decisions by comparing multiple facilities. And to do that, we're going to rely on something called FactoryTalk Innovation Suite. And really what this is our most forward-thinking platform of software. It's powered by a company called PTC, who has been doing IoT engagements for a very long time. And really what we're doing is taking that same technology that's being used in commercial spaces. Think of applications on your iPhone that connect up to clouds and different devices that connect to the cloud, things like smart homes, for example. We're using that same technology in the industrial space now. So really it's all about having enterprise-wide tools, and it starts with that layer that we talked about before with FactoryTalk Historian. If we can connect that data and have those events in that asset framework at a local level, we can then take that data and shift it into our visualization suites, whether it's Vantage Point or others. But then we can take that into more of an analytics suite. So FactoryTalk Analytics is a platform dedicated around machine learning and AI, and then also move it into more of a system approach, and that cloud approach, whether it's with Microsoft and their tools, with Power BI, whether it's integration with things like Outlook. Really, we want to leverage those cloud connectivity tools to take multiple sites that have Historian, aggregate that data all together, and really present something of value to you that you can use moving forwards. The traditional approach for things like machine learning and aggregating all this data, essentially what we do is we take a group of data from different places. It's very disparate in its approach. And so we take some data from a historian, we take a little bit from MES, from log files, maybe some data from your ERP. And really what it takes is a data integration engineer to create a data warehouse. Right? So what they're going to do is all of these islands of information, they are going to bring all that information in and then centrally store it in a data warehouse somewhere. Right? So that involves a second set of requirements to store all of that data. And then once they have that data, it's going to take a data architect and some kind of data engineer to really provide some analytics on it, right? So they're going to have to do multiple mashups. They're going to have to understand what the need is for that analytics. And then it's going to take an engineer to figure out what to do with that data. And really that takes a very complicated approach, and it takes a lot of heavy lifting from senior engineers to really do that data analysis. So what our approach is we're going to start with that same disparate data, right? We're still going to take data from your historian, from your log files, or your equipment in general. But what we're going to do, instead of warehousing it, we're going to do what's called orchestration. So we're not going to take that data and restore it somewhere else and then try and mash it together. We are going to connect directly, kind of as a client, to all of those disparate data sources. And we're going to try and ingest that and host it and stage it together. So we're going to try to align that data where we can and give you data that matches from different systems and make it easy to connect that data together. And really the intent here is that this doesn't take an engineer, a senior level data engineer to do, and we are not creating additional needs for connecting databases together. We're simply going to connect as a client to the different data sources and try to match that data together. And then we're going to provide a suite of tools around self-service analytics, right? So tools that are pre-made to help you do predictive maintenance, to help you operationalize your analytics and really make some real-time decisions based on machine learning and augmented reality, and really make it simple for you to provide that analytics so that you don't need a high-level data engineer to really understand what your data is. But really, anybody can subscribe and create their own analytics report. Okay, and the tool that we use to do that is something called ThingWorx, and ThingWorx really can connect to a whole host of different platforms. So we can take data from maybe SAP or some other ERP system that you have. We can take it from the FactoryTalk suite. We can take it from third-party HMIs and controllers. We can take data from Office 365 and other Microsoft tools, right? And what we do is we connect to all of these data sources and we host it in ThingWorx. And then ThingWorx is going to mash that data together, help us make some smart choices in terms of what data is important and what isn't. And then it's going to push it out to different tools, whether it's Dataflow ML for machine learning, it's DataView to be able to view that information and do a little bit more analytics, and Euphoria to do some augmented reality type solutions. And what we really want to focus on today is that DataView piece and how DataView is different from Vantage Point, which comes included with Historian. And really the main difference with DataView is it's an expansion of tools that we have today. So not only on the left-hand side here does it help us add connections into SQL and FactoryTalk, live data, and then Historian, it also lets us connect to things like web data. So think about connecting to things like the price of energy or the temperature throughout the day. If that affects your production based on the temperature of the facility, that's something we can ingest from different web data sources. We can also connect to other IoT hubs where you might have other information that you want to view together with your production data. And really, we take all of this data and we do data mashups here in the center, and we create storyboards. And what those storyboards are intended as is those dashboards that you can quickly look at and make smart decisions based on the information that's available. So really, it's all about an expanded tool set with DataView. It's about being able to do predictions and give you valuable reporting. It's about having multiple options to create storyboards and different charts. And it's really intended as a tool for collaboration and monitoring the system and understanding what your production system is doing. So that's the end of today's presentation. We appreciate you joining us for 30 minutes here. We hope that was an informative session for you. If there are any questions, please feel free to type them in the chat at this time, or you can unmute your microphone and ask any questions that you may have. If you don't have any questions, we appreciate you spending the time with us. We hope you have a good rest of the week and enjoy the weekend, and hope you join us next week. Thank you very much for joining us. I see Hector, you may have a question. Can you unmute yourself, Hector? I'm going to take that as a no. Is there a chat question?
Yeah. Hey, Martin. Yeah, he asked price and availability.
Definitely. So there in the pricing end, we have multiple options. We offer both a subscription model where you can adjust year to year on what your needs are and how many tanks you need, and then we offer a perpetual model where you own the licenses, and then we strongly recommend a support contract to go alongside that. From a licensing perspective, for Historian, the way it's licensed is by the amount of tags. So based on how many data points you want to connect to and how much information you want to collect, that is how we're going to license it. And there are multiple bundles depending on the amount of tags you want to do. And then for things like Vantage Point and DataView, it's more around, for DataView, it's around the amount of storyboards you want to create. So how many different storyboards do you want to have? How many different visualizations do you want to create? And then for Vantage Point, it's more around how many users want to connect to the system. But essentially, they're flexible models that scale up and down. From an availability standpoint, we can deliver the software in less than 24 hours. It's readily available. It's easy to download. There are multiple versions available, and I always recommend running with whatever we have in use, so that you get the latest features and benefits. But hopefully that answered your question. But if you have any more specific questions around pricing and availability, we'd be happy to work with you. Feel free to reach out either to myself or anybody on the team or your local one-source salesperson. We'd be happy to provide pricing for you.
Hey, Martin, can Chili unmute the mics? Maybe that's why he can't. But he also asked, can we buy ThingWorx with PTC or RAI?
So for ThingWorx, it's best to purchase it through the Rockwell end. We have multiple integrations that we can help you integrate to specifically Rockwell data sources, but also third party. If you think of PTC, they originally created the software, but it was intended as an IoT tool, not as an industrial tool. So what we did is we improved upon PTC's ThingWorx. It's still built on the same platform and the same foundation. But when you purchase through Rockwell, you're getting the industrial side support, and you also get support from Rockwell. We can offer services to help you set it up, and you get a better understanding of the industrial space than you will purchasing directly from PTC. And there is no difference in the cost of either purchasing through us or purchasing directly with PTC. Hopefully that answered the question. I am very sorry we cannot figure out how to unmute.
Yeah. I'm just monitoring that. Okay. Awesome. Thanks. I'm interested in ThingWorx for IoT devices for sure. Also, I don't have a mic on the computer I am using. Okay. Yep.
Okay, no problem, Hector. Well, we appreciate you typing in the questions, and either myself or somebody on the team will be reaching out to you here in the next few days. we'd love to set up a follow-up discussion, talk a little bit more about ThingWorx and kind of the power that it can bring and what your specific use case might be. We'd love to set up a follow-up discussion.
Cool.
Are there any other questions that I can help answer?
Nope, I think that's it. He said, thanks, we appreciate it.
All right. Well,
Thanks,
thanks
Hector.
everybody for joining us. Thank you, Hector, for your questions, and we'll reach out to you here shortly.
Okay, thanks, Martin.
Thank you, everyone.
Bye.
Thank you, Shelley. I don't know if you can hear me. Hopefully you can. But thanks for all your help, and thanks, Adrian, for muting halfway through the.
Sorry about that, guys.
Yeah, no problem. I was trying to politely nudge you to mute,
Yep.
but no worries. It
Got
wasn't too bad. It was just a little bit of background noise, but yeah, no worries.
Yeah, I thought we were muted when we came out of that thing for whatever reason, but it unmuted.
Yeah, I'm not sure what happened there, but no worries. It was I think it was fine. And Shelley, thank you very much for all your help.
Yeah, thanks, Shelley. Thanks, guys.
All right, thank you. Have a good one.
Bye.